Hi everyone, let's take a look at another example of geometry properties and proofs in triangles. This time we are visiting example number 2, where we are given the triangle DEF with vertices as at D, E, and F, and we are given the coordinates respectively 5, 2, 0, 3, and 4, negative 3. Now we have to describe how we would verify that the triangle DEF is an isosceles triangle. And then we have to verify whether the triangle is an isosceles triangle. So two things are going on here, or two things we need to answer. First of all, we have to describe how we can verify that this is an isosceles triangle. Now, remember that to describe means to use words to explain the process of or the strategy that we are going to follow to verify that the triangle is isosceles. And then we have to verify. Now, to verify means to perform all the calculations and confirm whether or not, based on your calculations, whether or not the triangle is indeed isosceles. So first we're going to start with a description. Now, the key word in our case will be isosceles triangle. So to verify that it is an isosceles triangle, we need to know what an isosceles triangle is first. So we're going to say that an isosceles triangle means that two of its sides would be equal in length. Therefore, if we want to prove that a triangle is isosceles, then we need to find the lengths. Obviously, we have to find all three lengths to check and see which ones, compare them and see which ones, if that's the case, are equal to each other. So we find all three side lengths and then compare. So our job now is to verify whether this is going to happen or not. So let's see. We have to first list the coordinates. I like to list the coordinates of the three vertices vertically. And generally, whenever I solve problems in analytic geometry, better to list the coordinates of points vertically because it's easier to grab the y's and the x's together. And remember that we usually want them together when you find delta y over delta x for the slope, or when you find the midpoint when you have to add the x's and find half of it, etc., etc. So we're going to start off with the length of the side DE. Now, the length of side DE, we're going to use the length of a line segment formula, is square root of, and we're going to go x at E minus x at D squared, and then plus y at E minus y at D squared. Now, remember that this has to be a difference, and we have the sum of the squares. That's the length of a line segment formula. Now, the order won't particularly matter in this case because we're going to square the answer anyway, so we're going to get a positive number regardless. But just to be following proper form, then I am going to start from the end of the line segment, subtract the beginning of it. Now, next we have to substitute the coordinates. And as I said before, it's easier to grab the coordinates. Look at that, 0 minus 5, 3 minus 2. So you don't have to jump horizontally over the line. So open brackets again, 0 minus 5, close brackets to the power of 2, plus open brackets again, 3 minus 2, close brackets to the power of 2. Simplify some more, and then we get negative 5 to the power of 2. Remember, negative 5 in brackets, the entire thing is squared, and then plus 3 minus 2, which is 1 squared. Simplify some more. Negative 5 squared is a 25, positive 1 squared is a 1, and we get that the length of DE is equal to the square root of 26. Normally, we try to also simplify the square root if possible, and we do this by taking out the perfect square factors, but in this case 26 only has the factors 2 and 13, both prime numbers, and neither one of them are perfect square factors or numbers, so that should be the most simplified form. Now we'll continue with the next side length, E to F. So E to F. So we're going to find the length of it as the square root of, so we're going to go x at F minus x at E. So write down in brackets x at F minus x at E to the power of 2 plus y at f minus y at e to the power of 2. So we'll substitute the values. So 4 minus 0 squared. So 4 minus 0 squared. And then plus negative 3 minus 3 squared. So negative 3 minus 3 to the power of 2. Now simplify. Always remember that this is still inside the brackets to the power of 2. So 4 squared. And this is still inside the brackets, negative 6 to the power of 2. Simplify and we get 16 plus 36. And that will give the square root of 52. That would be the length of EF. So far, no luck. We don't have two equal sides, so we have to keep searching for the third side in the triangle. So this time we're looking for DF. Remember, these are the only possibilities of forming lengths, right? So DF would be equal to square root of, again, from D to F. So x at F minus x at D squared plus x at F, y at F minus y at D squared. So let's write this down. So y at F minus y at D squared. Now we'll substitute the values. So we have 4 minus 5 squared. And then negative 3 minus 2 squared. Simplify, and then we have 4 minus negative 5 would be equal to negative 1. Remember to keep this inside brackets. It's a very common mistake people make, and then sometimes end up with even negative numbers inside the root. And then we think, oh, there is no solution. Well, there should be a solution. Just have to be very careful with the powers of 2. And then plus negative 3 minus 2 is negative 5 squared. And that will be 1 plus 25, or square root of 26. And that would be the length of DF. So as you can see here, we have the side lengths DE equals root of 26. We have the side length of, sorry, let me just box this up. The side length EF equals a root of 52. And lastly, we have square root of 26 equals DF. We have DF and DE equal to each other. So that proves that the triangle DEF is indeed isosceles. And where would you say is the angle, right? What are the equal angles in this case? So I want you to think about it. So if they are equal, so DE and DF are equal, then angle D is the angle from where these two equal sides are coming from, right? So this would be the angle D, and right at the bottom we'll have the side EF. So this would be E, this would be F, which will make the angles E and F equal to each other because these two side lengths are equal. I hope that you found the instructions helpful. Thank you for learning with me, and bye for now.